Okay, so section 3.4 is additional topics in probability and counting. And so the first thing we have here are these things called permutations, okay? So it says a permutation is an ordered arrangement of objects. The number of different permutations of n distinct objects is n with an exclamation point. The way we read that, guys, is n factorial, okay? So when you see n with the exclamation point, it doesn't mean like n. It means n factorial, okay? And what I'm going to show you exactly what factorial means in the first problem here. It says, in how many ways can 5 books be ordered on a bookshelf? Okay, so we have 5 books, and we're going to put them on a bookshelf. 4, 5. Okay, so in the first spot, I can put 5 books. Now we've put 1. Now I can only put 4 books. In the second one, I can choose from 3 in the third. I can choose from 2 in the fourth, and I can choose from 1 in the last. And this is what 5 factorial means. It means 5 times 4 times 3 times 2 times 1, and that should give us 120. Okay. Let's see. John, Carlos, and Dan are racing each other, and how many ways can the 3 runners finish the race? Okay. So we can have John in the first spot, Carlos or Dan. Once we pick 1, now we only have 2 we can choose from, and then once we pick those 2, we only have 1 we can choose from. We will multiply, and that's going to give me 6. Okay. Now it says, if you want to take only some of the objects from a group and put them in an order, then we're going to use this formula right here. Okay. And it's NPR, okay? And it says the number of permutations and distinct objects when we're only taking R at a time, okay? Let's see. It says a race consists of 15 runners, and how many ways can there be a first, second, and third place winner? Okay, so that means we can choose from the first spot, we can choose from 15. The second spot, we can choose from 14 other runners. And the third spot, we can choose from 13 other runners. And we're going to multiply those numbers together, okay? So let me grab my calculator, and I'll show you 2 ways of doing this, guys. It's 15 times 14 times 13, which was 2730, okay? Oops, 2730, okay? So think about it this way. We have 15 runners, and we're going to choose 3 places. So the way I would do this is 15 permutation 3. And so just to give you a heads up, the way you can do this on your calculator, let me bring this over, let me clear it out. I'm going to hit stat, and I'm sorry, quit. Okay, I'm going to hit math, and I want to get to the probabilities. So there's 2 ways I can get there. I can just keep doing this until I get there, and here we go. Okay, so first, before I get there, I'm sorry, let me go 15, math. Let's get to our probability. And I'm going to choose number 2 because I want the NPR. So 15, what's my next number? 3. Enter, and notice I came up with the same number, 2730. It's right there, okay? All right, so here's the next one. It says, a DJ is preparing a list of 24 songs, and how many ways can the DJ choose the first 6? So 24 permutation 6, okay? Let's see, so we're going to go 24, math. Again, if I want to get to probability, instead of hitting this one 4 times, I can hit the one on the left once. Choose that one right there, and 6. And wow, that's a lot of different ways, right? So 969, 09, 120. 969, 09, 120, right? Okay. The starting lineup for a softball team consists of 10 players. And how many different batting orders are possible using the starting lineup? Well, let's figure it out. Okay, so let's see. We're going to have 10 permutation 10. Okay, so let me grab my calculator again. 10, math, probability, permutation 10 again, and 362, 8800. 362, 8800. Okay. All right. Now it says, now imagine you'd like to reorder the following letters, A, B, B, C. And how many ways can you arrange the 7 letters, and how many will be unique or distinguishable? So what we mean by that is, if you look at the letters here, the A's repeat and the B's repeat. So the point that we're trying to make here, guys, is if we switch those two A's, and you looked at this and you looked at this, we wouldn't be able to tell that we switched them, right? How would we know that? So it says the number of distinguishable, which means different permutations of n objects, where n1 are of one type, n2 of another type, is so on and so forth, is given by this formula right here. Okay, so now it says, how many distinguishable permutations are there for the 7 letters of AAA, BBC? Okay, so it tells me how many letters there are. There's a total of 7 letters here, so we're going to write 7 factorial. Okay, how many A's do we have? We have 4 A's, so we're going to put 4 factorial. How many B's do we have? We have 2 B's, so we're going to put 2 factorial. How many C's do we have? We have 1 C, so we're going to put 1 factorial. Notice, guys, if I were just to take the numbers 4, 2, and 1, add them together, that would give me 7. All right, let me grab my calculator again and clear it out. So we're going to go 7 math. I want to get to the factorial button, which is the exclamation point. There we go. Divided by, now I'm going to put all this stuff in parentheses. So I'm going to put 4 math factorial times 2 math factorial times 1 math probability factorial. Close it off, hit enter, and I'm coming up with 105. Okay, so guys, this is just a little side note. When you have the number 1 factorial and we're putting it in here in my calculator, I want to show you that I don't actually have to do that, because 1 factorial is really the same thing as the number 1. And remember what happens when you multiply by 1? It stays exactly the same. So notice, if I take out the 1 here and I hit enter, I still come up with the same number, 105, okay? So I'm showing you this. The reason I showed you the first time was I want you to understand that 4, 2, and 1 need to add up to that number there. But the reason why I'm showing you this part now is time-saving technique, right? You don't have to type in the 1, because 1 factorial is always going to be 1, all right? Okay, so now let's take a look at the next one here. It says a building contractor is planning to develop a subdivision. The contractor wants to plant 6 oaks. So 6 oaks. Let's see, 9 maples. Let's get rid of that. That looks like a pretty messy maple. And 5 poplar trees. Okay. The trees are to be spaced evenly, and how many distinguishable ways can they be planted? Okay, so first thing we're going to do, 6, 9, and 5. So 6 and 9 is 15, and another 5 is 20. So it's going to be 20 factorial divided by 6 factorial, 9 factorial, 5 factorial. All righty, so let me come back here. And let me see if I can do something here, guys. Yeah, so look, I'm going to delete that. Then I'm going to insert the number, what is it, 20? There we go. I'm going to delete that number, but I'm going to insert the number 6. And I'm going to delete that, but insert the number 9. Okay. Times... what is it, 5 factorial, 5, math, factorial, enter, close off my parentheses, and hit enter. and 7759, 7520, 7759, 7920. Is that right? I already forgot. 7520. Oops. Fix that real quick. Boom. 7520. There we go. All right. So, number 8, same type of problem, right? How many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 factorial. Okay. How many m's do we have? We only got one m, so 1 factorial. How many i's? 1, 2, 3. There's 4 i's. How many s's? Looks like there's 4 s's. How many p's? There's 2 p's. And that should be it. Let's see. Let's make sure we're doing this right. 2 and 4 is 6. 4 is 10. 1 more is 11. Perfect. Okay, so guys, remember when I do this on my calculator, I'm not going to worry about the 1, right? So let's do this. Second entry pulls up the last thing I typed in, okay? So I think I can even just go 11. Yep. And again, I won't worry about the 1, but I'll put a 4 here. Put another 4 right there. And back 1 and put a 2 right there. Okay. And now we'll hit enter. And 34,650. 34,650. There we go. Okay. So now we have something called combinations. So it says if the order of the items selected from a group does not matter, we're dealing with combinations as opposed to permutations. So guys, permutation, the order is important. Combination, the order is not important. As an example, consider a class of 25 students competing for the top 3 slots in a friendly review game. How many ways can the students finish first, second, and third? Notice that the outcome of Daniela, Kevin, and Elizabeth is a different outcome from Kevin, Elizabeth, and Daniela, because the first one goes to first place, then second, and then third. Let's see. Now, it says, consider the same class of 25 students, 3 students to be chosen at random to represent the class at a regional competition. Notice how the 3 students can be chosen. Notice that the outcome, Daniela, Kevin, and Elizabeth, is the same as Kevin, Elizabeth, and Daniela. The order is not important when we're just choosing people to go do something randomly, right? But if it's for like positions like first, second, and third, or president, vice president, secretary, that would be permutation, okay? So here we have a combination formula. The number of combinations of R objects selected from N objects without regard to order is given by NCR, okay? It says the manager of an accounting department wants to form a 3-person advisory committee from 20 employees in the department. How many ways can the manager form this committee? So we have 20. We're going to choose 3. Okay. So I'm going to grab my calculator. I'm going to go 20, math, probability. I'm going to go to my combination one right here, enter, choose 3, and we came up with 1140. Okay. I want you to notice that a lot of these problems, guys, really are calculator type problems. Okay. I'm going to be using my calculator. I don't want to be using like the actual formula where I have to do this computation, because this is going to be, unnecessary. From a group of 40 people, a jury of 12 are selected. So again, we're going to go 40, choose 12. So let me grab my calculator again. And I'll tell you what I'll do. I'll do the same thing we did before. Come back over here. Let's go 40. And we're going to choose 12. And now that's a lot. So 5586. 5. Oops. Come on, pen. Oh, come on. Sorry, guys. There we go. 5586, and the rest of it, which was 853,480, 853,480. A lot of different ways, right? Okay. Let's see. A lottery has 52 numbers, and how many ways can 6 of the numbers be selected? So 52 choose 6. Have you all ever watched the lottery? They usually show it on the news right before the news starts. And the order of the numbers is not important. So as long as you got your 6 numbers, you win the jackpot, right? So 20, 35, 85, 20. 20, oh, come on, there we go. 20, 35, 85, 85, 20. All right. So let's take a look at the next part here. It says a restaurant offers you a dinner special that allows you to choose from 12 entrees, 10 side items, and 13 desserts. We can choose 1 entree, 1 side dish, and 2 desserts. How many meals are possible? Okay, so we're going to do it like this. We're going to look at our entrees, we're going to look at our side dishes, we're going to look at our desserts. We have 12 entrees, and we're going to choose 1 of them. Okay. Side dishes, we have 10 side dishes, and we're going to choose 1 of them. Okay. And desserts, we have 13 desserts, and we're going to choose, they're so generous, 2 of them. And all we're going to do, guys, is do this computation and multiply and get our answer, okay? So let me move this over here. And I'm going to type it in exactly as I have it here. So we notice I got parentheses. Let me put parentheses in. 12, math, choose 1 times, let's see, 10, math, choose, choose 1 also, okay, and parentheses and times, parentheses again, 13, math, choose 2, close it off, hit enter, 9360. Okay, so we can choose, or we'll have a total of 9,360 possible meals. Okay. Let's see. An environmental agency is analyzing water samples from a total of 80 lakes for pollution. 5 of those 80 have dangerously high levels of dioxin. Now, 6 lakes are randomly selected from a sample. Using a calculator, how many ways could 1 polluted lake and 5 polluted lakes be chosen? Okay, so let's think about it this way. We have a total of 80 lakes, right? How many of them are polluted? 5. So how many are not? 75, right? Okay, we're going to choose a total of 6. So we're going to choose 6. And we want to have 1 polluted lake, and 5 non-polluted lakes. Okay, so non-polluted. So out of those 75, we're going to choose 5 of them. Okay. And then out of the 5 that are polluted, we're going to choose 1 of them, and that'll be my answer. So guys, just because it takes me a whole lot of time to do it on the calculator, and I showed you how to do it, I'm going to leave the computation to you, but you know, it was the same thing like when we did this problem here. Okay. So let's see. Permutations, order is important. Combinations, the order is not important. Okay. So just to kind of give you a little synopsis, if they're asking for like first, second, third permutation, president, vice president, secretary permutation. If they're just asking you to choose 5 out of whatever, it's going to be a combination. Okay. So now let's talk a little bit about finding probabilities. It says that recall to find the probability of an event, you must determine how many outcomes are in the event out of how many total outcomes are in the sample space, or at least possible. It says, what tip, when deciding between permutations and combinations, ask ourselves if the order of the selected group matters, meaning if a different arrangement of the group represents a different outcome. If it does, then we use permutations. If it doesn't, we'll use combinations. Okay, so it says, in a class of 25 students, 2 students are chosen at random. What's the probability that the 2 students chosen are Amanda and Sophia? Assuming that there's only one Amanda and Sophia. Okay, so let's think about it. Suppose we choose Amanda and then Sophia. Would that be any different if we chose Sophia and Amanda? No, because we're just choosing those 2. Those 2 are not going to be president, vice president, secretary, vice secretary, whatever, right? First or second. They're just being chosen. So there's only one way of choosing. Why is my pen not working again? Okay, there's only one way of choosing Amanda and Sophia. But how many ways can we choose 2 students? Well, we have 25, and we're going to choose 2. Okay. So, guys, for these problems here, you are going to be writing them in decimals. And again, we'll be going to 3 decimal places. So I'm going to go 1 divided by, I'm going to do 25, math, choose 2. And here we go. So 0.003. Okay. And again, I'm using 3. If my math lab would tell me I needed to write 4, then I would have just added another 3. Okay. So you'll write whatever my math lab is asking you to write. Okay. Now it says an advisory committee consists of 3 members. The 3 members randomly will be selected as president, secretary, and treasurer. What's the probability that Mario will be president, Francisco will be secretary, Yasmin will be treasurer? Okay, so that is 1 order, okay? So now this is going to be 1 over. But because the order is important here, guys, I'm going to be using permutation. So let me grab my calculator again, and I'll tell you what I'll do. I'll do it like this. I'm going to change that 25 to an 18. And then I'm going to go math, probability. This is now a permutation. So permutation, I'm going to change that 2 to a 3. And, okay, so notice my number came out in scientific notation. So I'm going to write it for you in scientific notation, and then I'll show you what it means as a regular number. So 2.04, and then there was a bunch of other stuff, and it had an E. Was it in a -4, I want to say? Yeah, -4. Okay. So what this means is 2.04 times 10 to the -4. All this means I'm going to do, guys, is I'm going to take my decimal point right here, and I'm going to move it a total of 4 spaces. Okay? So look, that's 1 space already. That's 2, that's 3, that's 4. So I got to put 3 zeros. 2, 3, and I'm going to put it 2, and I'll stop right there. Okay? All right, so let's take a look here. It says a warehouse employs 21 workers on the first shift, 19 on the second, 10 on the third. 8 workers are chosen at random to be interviewed about the work environment. Find the probability of choosing exactly 5 first shift workers. Okay, so let's figure out the total number of workers that we have. 21 to the first, 19. 21 to the first, 19 on the second, 10 on the third. So let me add those numbers up together. So 21 plus 19 plus 10. What's that? 50? Okay. So we have a total of 50 workers. How many are we going to choose? We're going to choose 8. So my denominator is going to be 50, choose 8. Okay. We want to find the probability of choosing exactly 5 first shift workers. So out of the 21 that work on the first shift, we're going to choose 5. Now, the other 3 are going to come from the second and third shift. So these, what's that, 29 workers now? We're going to choose 3. Okay. So let me grab my calculator again. And I'll do this in parentheses, so I'll go 21, math, choose 5. Oops, clear that out. Try it again. Okay, 21, math, choose 5, times 29, math, oops, choose 3, okay, divided by 50, math, choose 8. And hit enter. And so I'm coming up with, if I go to 3 decimal places, 0.138. 0.138. Okay. All right. So this one here, guys, is not 167, it's number 17. A race has 12 entries, assuming there are no ties. What's the probability that 3 horses owned by one person finished first, second, and third? Okay, so let's go ahead and figure this one out. Okay, so it says, assuming there are no ties, what's the probability that 3 horses owned by one person finished first, second, and third? So those 3 horses, guys, whether like, say, I don't know, Prickly Pete, Snoopy, and, I don't know, Lucky. Say those are the 3 horses, right? It really wouldn't matter if this is first, second, and third, or this one is first, this one is second, this is third, because his 3 horses still got first, second, and third. They don't really care what order this one is in, right? Because they're all going to belong to the same guy. So we're going to do a combination. We're going to say 12, choose 3, because we don't care as long as his 3 are in that group. So let me grab my calculator. Let's clear this out. Let's go 12, math, choose 3, 220, okay? And the probability will be 1 out of the 220, right? Because it'll be one way that can happen, because it doesn't matter the order of them. And so now if I just take my calculator again and go 1 divided by 220, it is 0.0045, 0.0045. And finally, I think this is our last one. It says the manufacturer is analyzing a sample of 400 corn kernels for the presence of a toxin. In the sample, 3 kernels have dangerously high levels of the toxin. Okay, so we have a total of 400. Okay, so the ones that have the toxins are 3. So the ones that don't would be 397. We're going to choose 4 kernels. What's the probability that exactly 1 kernel contains a high level of the toxin? Okay, so let's see if we can't figure this one out. Oh, there we go. Okay, so my denominator, we have a total of 400 kernels, and we're going to choose 4 of them. Okay, we want to have exactly 1 kernel that has the toxin. So we're going to choose, out of those 3, we're going to choose 1. Out of these 397, we're going to choose the other 3. Okay. And again, I'll let you do this on the calculator, and then you can figure out what number you're going to end up writing there. Make sure you put the little dot, and that was 3.4.